Hi guys, so I want to do an example of the conservation of energy for a roller coaster, and I want to do it where it's frictionless, and I want to do it where we have a non-conservative work, so you can see how this is done. Okay, so a little glare there. So I have a 2,000 kilogram car, 80 meters high, at point A, slides down, goes back up the hill at B, which is 20 meters high, okay? We want to know how fast is this car moving at B. So the first thing we look at, we say, okay, what do we have here, all right? Now, I'm going to give this an initial velocity of 2 meters per second, okay? So we have kinetic energy, KE equals 1/2 mv squared. So this is 1/2 2,000 times 2 meters per second squared. We get 4,000 joules. Now it also has potential energy here because of the height. And potential energy equals mass, gravity, height. So it's 2,000 kilograms times gravity, 9.81, times the height is 80 meters. So 2,000 times 9.81 times 80. One 569,600 joules. So you get 1.5 million joules of energy. That's a lot of energy. Okay. So now we come over to here at B. All right, and we say, okay, we're at 20 meters high. What does it have here? It has potential energy, right? So potential energy, GH. So we have 2,000 times 9.81 times 20 meters. 2,000 times 9.81 times 20 meters is 392,400 joules. So 392,000 joules here. Okay. So now we have potential energy at the top plus kinetic energy at the top equal to potential energy at the bottom, which we'll call place B, all right, plus kinetic energy at the bottom. We'll put our stuff in here, so we have potential energy at the top is 1569600 joules plus the kinetic energy 4,000 equals 392,400 joules plus kinetic energy at the bottom. So we have 1569600 plus 4,000, and I subtract this over, minus 392,400, and the kinetic energy at the bottom is equal to 1181200 joules. So the kinetic energy equals 1/2 mv squared, 1181200 equals 1/2 2,000 kilograms times v squared. So times 2 divided by 2,000 gives us 1181.2 equals v squared. And we square root both sides, and v comes out to be 34.37 meters per second. So if this is a frictionless setup, okay, when it goes from here down to here, all right, we end up with a speed of 34.37 meters per second. Now, I could ask you, and say, all right, we know that it's not frictionless on a roller coaster, and what if I said to you that the new speed, instead of 34.37, is 25 meters per second? All right, so I'm going to say that the new speed, V new at the bottom, is 25 meters per second. We want to know what is the non-conservative work for this. All right, move my camera over. Okay. All right. So we leave the beginning here the same, potential energy at top plus the kinetic energy at top, right? And then the after section is down here. Okay. We're going to use the 25 in this formula here to find out how much kinetic energy it actually has at the bottom. Okay. So for this scenario, we would do KE at the top plus PE at the top equal to KE at the bottom plus PE at the bottom plus non-conservative work. Okay? So we already got our numbers. 1569600 plus 4,000 joules equals kinetic energy at the bottom. We would do 1/2 2,000 kilograms times 25 meters per second plus the potential energy, which we calculated as 392,400 plus non-conservative work. And that's a squared. Okay. So we'll do this here. We got 1569600 plus 4,000 gives us 1573600. All right. And then 0.5 times 2,000 times 25 squared gives us 625,000 plus 392,400 plus MC. So we get 1017400 plus WMC equal to 1573600. Subtract this over. 1573600. And we get 55,000, or no, we get 556,200,000 joules is the non-conservative work. Okay, so that is what that would be. So if I gave you a question and we wanted you to calculate what the non-conservative work was, that's how you would do it. Okay, the other way that sometimes it's done is they put the non-conservative work here at the top and they put it in as a negative. All right, either way it's fine. It's just semantics. Okay, as long as you know what you're looking for. All right, thanks.